Okay, in this mini lecture, I'm actually going to conduct three difference of means tests. You can look over here to the left side of the screen. I'll first conduct a two-group difference of means test. Then with really the same data, I'll conduct a one-group difference of means test. And then finally, I'll conduct a paired comparisons test. Let me give you just a little bit of background on this data first. Um, and I think, in fact, I'm pretty sure I've already distributed a memo that contains all of this. So this is just kind of putting to a mini lecture what's in the memo. We had a situation where there was an individual who developed a program to teach kids math over a period of 6 weeks. So we took one sample of 10 students from a third grade class, okay? So we had student number one, student number two, all the way down to student number 10. We gave each kid a standardized test, okay? So on the first exam, child number one scored 78, child number five scored 71, child number 10 scored 72 on the first exam, okay? Then we had these 10 children go through the 6 weeks of math training that this individual had developed. And he claimed, as you can see up in the gray text on the screen, he claims that this math program will raise children's scores by up to a full letter grade, which I found ambiguous if not misleading. Nevertheless, we tested the program by administering the exam number one, as you see here. Then we had each of these 10 children do the 6 weeks of math training program. And then after the 6 weeks of math training program, each kid took the same standardized test again. So we could look at this as a two-group difference of means test. We could ignore the fact that the same children took each of the tests, okay? So we could ignore the fact that each child took two tests, and we could merely treat exam number one as one group, we could treat exam number two as two group, and we could do a two-group difference of means test with independent groups, essentially comparing a mean of 78.7 to a mean of 80. Okay, we could do that. So let's go through that process and see what our Megastat results demonstrate or show us. So the first thing that we'll do is we'll click on add-ins, and as always, when we're gonna get to Megastat, we go through add-ins. We then drag over to Megastat, as you can see here, and we click on Megastat. We drag down to hypothesis tests, and then since we're going to compare two groups, and it says here two independent groups, and if we ignore the fact that the same kids took test number one as test number two, we can treat them as independent groups. We don't have to take into consideration the fact that the same 10 kids took each of the tests. And then we'll just set up here to where for group number one, let's consider that exam number one. I'm sorry, exam number two. And for group number two, we'll call that exam number one. Hypothesized difference, we'll treat it as zero. Okay, might be a difference, might not. We'll work with the t-test because of the small sample. 95% confidence interval is we'll always work with unless I indicate otherwise. And we will ask for the computer program to give us our upper and lower bounds of our interval estimate. I'll work with unequal means here at this point. If I was to do anything to this, I would set my alternative up as my alternative up as greater than. But for the moment, we'll just leave it as a two-tail, and then we click on OK. You see the results here, the descriptive statistics. Let me make this just a little bit bigger so it might be easier to see. Okay, you'll see that our descriptives here in the highlighted area match what we had on the previous screen for the descriptive statistics. I'll immediately direct your eye down to this part of the output where our observed t-value is 0.359. Let me remind you, Megastat does not calculate the observed, or I'm sorry, Megastat does not calculate the critical t-value. It instead provides us the observed t-value. So if we were to look up the critical t-value here, it would be quite a bit larger than 0.359, I can assure you. Recall that our critical p-value was 0.05, and since our observed p, 0.724, is larger than our critical p of 0.05, we fail to reject the null hypothesis. In other words, we conclude that the average score for exam number 2 and exam number 1 are not statistically significantly different from one another. Again, trying to develop your ability to bring in managerial insight, we see that the calculation for the margin of error is 7.614. So if we were to take our observed difference of 1.3 and subtract our margin of error, that gives us our lower bound of negative 6.3. If we add 1.3, our point estimate, to our margin of error, 7.614, that gives us the upper bound of our 95% confidence interval, 8.914. So again, we failed to reject the null hypothesis because of the large p-value. The rest of the story told here by the margin of error on our confidence interval is we're 95% confident, okay? We're 95% confident that the average score on exam number 2 was somewhere between 6.3 points lower than the first exam and 8.9 points higher than the first exam, okay? So clearly not much evidence here that there's a statistical difference between the two, given that between our lower and upper bounds, the hypothesized difference of 0 resides, okay? But when we look deeper, it's possible at the upper bound of our confidence interval, it's possible that they scored about 9 points better on the second exam than they did the first. At the lower bound, it's possible that they scored about 6 points lower on the second exam than the first. So I encourage you to continue to develop your ability to read and interpret this Megastat output, with particular emphasis on making sure you understand how to do the T and the P calculations to decide whether to reject or fail to reject the null hypothesis, but also to pay close attention to this margin of error and the confidence levels. Okay, so using that data back here, using this data, we did a 2-group difference of means test with independent groups. Alternatively, if you'll remember in my one memo to you, I indicated that we could do a 1-group difference, or I'm sorry, I indicated that if we do a 1-group difference of means test and a paired comparisons test, computationally you get exactly the same results. So now what I'll do is I'll work with the same data, but I'm going to run a 1-group difference of means test, and my 1 group is going to be this column here, okay? It's going to be my improvement column, and my observed mean for this column is 1.3. So on average, the improvement score was 1.3 points higher on the first exam than the second exam. But in this instance here, I'm going to be using the 1-group difference of means test to assess whether 1.3 is statistically significantly different from 0. So all we do is run the 1-group difference of means test. Again, this is our 1 observed group here. So let me just take you through the full routine. We first click on add-ins. We then drag over to Megastat. And we drag down to hypothesis tests. Now in this instance, I'm going to conduct a mean versus hypothesized value. My observed mean is 1.3 points. My hypothesized value will be 0, so I'll click on this. And it asks for my input range. So for my input range, I highlight my column of interest. Now notice here, as I've always done in the past, I highlight the column title, improvement, as well as my numerical data. Hypothesis, hypothesized mean. I'm hypothesizing a mean of 0, okay? And I'll do a two-tail alternative. I'll ask for a 95% confidence interval. Keep with the t-test because of our small sample size. And I now click on OK. And here you see our results. Again, I'll direct your eye first here, and you see that the p-value is 0.7213, which is larger than our critical p-value of 0.05, so we fail to reject the null hypothesis. I'll ignore the discussion of the t observed value at this point. I'll assume by now you're beginning to understand how to work with that, and that ORIS does not provide us the critical t-value in the output. But let me also scroll up and compare it to our two-group difference of means test. And you'll see that the observed t-value and p-value are close, but slightly different than what we observed in the one-sample difference of means test. And the same can be said for the 95% confidence interval and the error term. Okay? And again, I'm not going to go over the arithmetic of that to explain why these results are very close but nevertheless different. But I will tell you, as a matter of routine, your results in the two-group difference of means test compared to the one-group difference of means test will be similar, but somewhat different. Nevertheless, here, notice we have a t-value of 0.368 and a p-value of 0.7213. And I'll just give you a glimpse. When I go back to the data now, I'm going to run the paired comparisons test. And in the paired comparisons test, although my process of inputting the data will be slightly different, I will get in the output a t-value of 0.368, and I'll get a p-value of 0.7213 as evidence that the one sample difference of means test, which ORIS calls mean versus hypothesized. So what I'm going to do now is demonstrate to you that the one sample difference of means test is computationally identical to the paired comparisons or to the paired observations test, because the results that we get here and the results that we get here on the next test will be identical to what you see in this area of the screen. Okay?